Okay, so now we will talk about reduction of order, section 3.2. What's the idea? We start with second order. And we're given a solution, y1, and we ask for a second solution. That would be linearly independent of y1. So this is from section 3.1. So as you learned in 3.1, the Wronskian of y2 and y1 is not zero. Okay, so we have to find y2. Now it turns out that a good guess, also called ANSAS, is y2 defined as y1 times some function ux yet to be determined. Okay, so now we will find want to find an equation for ux. Okay, once we find that, we will find y2. Okay, so so suppose y2 solves the ODE. So let me call it star. Okay, what do we have? We have y2 double prime plus px y2 prime plus qx y2 is equal to 0. Okay, so now use that y2 is defined to be u times y1. And I leave it as for you to show that indeed you get u times y1 double prime, y1 prime, qx y1 plus u double prime y1 to u1 prime y1 prime and p of x u prime y1 equal to 0. So what happened here? If you take derivatives, you will get some expression in terms of u and y1, and then you plug it in to the equation and you will get this new equation here. So give it a try to go from here to here. Okay, so once we're here, we can use that this is equal to 0 because y1 is a solution to star. Okay, so then we simplify to u double prime y1 and then p u prime y1 equal to 0. Okay, all right. Observe that we don't have any u term. Any term containing u so we can do a change of variables. W equal to u prime. And if we do that, the equation becomes w prime y1 2 times w y1 plus p w y1 equal to 0. Okay, so if we find w, we will find u prime, and by integrating, we will find u. But this is a separable equation. So let me rewrite it. So we divide by w. Okay, let me do a little. So this is du dx. And then w with minus 2y1 plus py1. I just brought it to the other side. Okay, and then we separate. So 1 over w to w, y1, and dx. Okay. This guy is log. And right hand side is 2 times log y1. So there was a derivative. So right, so here we have a derivative, right? So this is dy. Okay, so here this will give log if you integrate, and this one will give integral of p. Okay, so let me do this a little bit more slowly. So here we have minus 2. Let me put the integrals. dy1 over y1 and integral of p dx. Okay. All right. So now, if you take the exponential, so yeah, let me add the constant. So if you take exponential, let me do it slowly. So we have minus 2 log of y1 minus integral of px dx plus a1. So this is log. So we get 1 over y1 squared. This one stays as it is. And this one is a new constant, a1 tilde. Okay. So now let's find u. So w is u prime. So u is equal to the integral of w plus a2, which is the integral of y1 squared. Let's put t exponential dx plus so yeah, times a1 tilde plus a2. Okay, so we plugged in w in here. Okay, so okay, so a particular u is for a1 tilde equal to 1 and a2 0, meaning u is y1 squared e to the minus p dx. Okay. And so y2, the second solution, would be y1 times u of x. So y1 times integral of y1 squared times the exponential of the coefficient p. Okay, so that's the method